Hello. Okay, so stream should be up in few seconds. Let me reset the timer. Timer is reset. Timer has been reset. Now we can start. So let's take a look at coverage report. And local host 5500 coverage, and we're checking samples, right? Yeah, this part we we are not able to test for some reason. Let's go back to VS Code, and we know we are testing it here. Let's try to run forge test dash dash empty dash vvv 5 times. So we are testing it. It is returning the error, but we don't know why that line is not covered. Oh no, this is something else. Sorry, this is not this part. It's unit. Okay, this. We wanted to cover this this contract, and specifically this, whatever we you want to call it. Back to implementations. For some reason, let's try to run it again. No, we don't have to call back. EVM revert this. It says EVM revert, but it doesn't. For some reason, it doesn't actually. Just a second. Okay. It doesn't give us the value we wanted, which is this value. We know fallback is being called. Can we say RECEIV receive payable Okay, we got something. So for some reason, fallback wasn't returning this. We were able to revert, but not in a correct way, or it wasn't returning correct value. So here, instead of this, we'll say dot ABI dot encode with signature. Then signature will be error string, and then we can pass the string. Will this work? Okay. Now that's done. We'll just update the report. Tested coverage to 100%. Mocks account revert. Okay. We have to test this part where fail at least one of these should be called. If I know we are not calling both, but at least one should be called. And for this, it doesn't really matter. We can call entry point and just check entry point is entry point. Okay, before that, let me see. Validity fallback revert from fallback doesn't return any data. Why does fallback expecting a return value? No, maybe not. It does not track invalid explicit type conversion at runtime. It is then we go back and we'll change something here. So let's put like it's fallback. Oh, okay. So we were sending ether to non-payable function. So maybe that's why we were getting EVM error. Oh, okay, cool. Got it. Let's move this to its own file. We don't need. We already have this. What was the name? Okay. What we'll do is put this value here, remove this, import reverts on ether received from test slash mock slash dot sol. We can go here. We'll change this. Do we need to change anything else? Let's run the whole thing, forge test, and see how many places this thing breaks. None. That's cool. None. Implementations. Okay, that's good to know. Next part was, I think it was in mocks only. These two functions were not executed. I know we are testing them somewhere. Oh, okay. I'm pretty sure we can't test them right now because of we can't achieve that scenario. That's why we can't okay, encode. Back back to coverage report. Here we haven't tested these two functions, and that's okay because we are encoding them wrong for some reason. Go here, then user operation lib test, and this part abi.encode, and I guess we are taking the hashes are different in lib. what we can do is import console from forge std slash console2 console2 as console. Okay, so we have our thing, our console, and I want to see this console.log bytes32 hash init code. We have it, and I want to see hash of this console log bytes32. Now let's run the, okay, this is the name, forge test dash dash empty, and see the trace. Okay, are you getting me? Console.log. No, we have to call it. Values are correct, so no issues there. What, the init code is correct, hash is correct, user operation lab, put it this side by side. Sender will be address, nuns will be UN256, that's okay. Bytes 32, bytes 32, bytes 32, UN256, bytes 32, and bytes 32. Okay, let's try to create log log. Okay, here we want to bytes 32 log. Okay, we have init code, hash of call data, hash of account address, pre-verification gas fees. We'll do the same for everything here. Call data, then this part. We have to wrap it. Is that it? ABI.encode packed. We have everything, almost everything, not everything. Then this part. No, we have to, yeah, from here we have to remove this part, add this. That works. Let's run it. I know it will fail, but I just want to see the logs. Okay, those two values are there. These values are there. So if ED75, that's not there. Okay, why we are doing this? We don't need hash of that. It's already bytes 32. D40. Okay, some verification call. Verification call. Okay, somewhere in the test we are messing up. So packed max priority. Okay, understood. We are messing up here. And this. Let's remove everything. Let's run it. That test passes. So we can remove these. And here hash. Okay, so we have almost everything. No, we have covered almost everything in the user operation lab. Cool. Hello. Hi. whoever is the third person watching, hopefully it's not someone I know. Like if it is, just ping in the chat, like or something like that. Cool. Now, as I said, we can move on to BLS signatures and covering this part, handle aggregated user ops. So this part I haven't experimented with till now. I don't know anything about aggregators, anything about BLS signatures, or even any kind of signature that aggregates. I just know ECDSA and maybe this P256. So don't remember what kind of signature those are, but I think those are also ECDSA. Cool. Let's go to browser. ERC4337 EIPs. We are checking the specification and we want to learn about aggregators. Agree. Signature aggregation. Okay, that's a different EIP. I didn't know that. EIP 77766 signature aggregation for ERC4337 and ERC4337 improvement to aggregation of all user operation signature in a bundle. Vitalik was uh, drawer drawer Shah Shahaf Shahaf Alex. Okay, these guys 2024 9-1. Huh, I don't think. What is this? Okay, validation scope. This is not for. Yeah, this is not for the account. This is for bundlers. So we don't have to worry about that. I am planning to go through bundler and maybe rewrite the whole bundler in Rust or something like that. Something similar. Maybe Rust, maybe JavaScript. I don't know. But that for that I have to do some practice. Like most of the time I write in Solidity, so I don't have any experience with. I do have experience with other languages, but I'm little bit rusty there, like with those skills. Okay, let's read about this. Abstract ERC4337 defined a way to achieve account abstraction on Ethereum using an alternative user operation mempool. However, one big limitation remains: each transaction must carry its own signature or other form of validation input in order to be included. We propose an extension to ERC4337 to introduce an entity aggregator that is called during validation to validate multiple user op at once. This addition will enable user operations to support sharing validation input, saving gas, guaranteeing atomic atomicity of bundle. Okay, let's see if it calls handle user op. Handle handle. This method is called onchain by. Okay, so we are reading correct thing, which is how aggregated user ops will be executed basically. Or what? Just a second. I'll be back in a minute. Okay, now we can, what we can do is we'll just read this for rest of the 30 minutes. I don't know how much time it will take. Also, my reading speed is very slow, and I'm gonna read the words wrong most of the time. So just just try to do your best also with reading this. Okay, limitations that works. We propose an extension to ERC4337 that introduces a new entity aggregator that is called during validation to validate multiple user operations at once. This addition will enable user operations to support sharing validation inputs, saving gas, and guaranteeing atomicity of bundler motivation. Using validation schemes that allow signature aggregation enables significant optimizations and savings on gas for execution and transaction data cost. This is especially relevant in context of rollup that publishes data on Ethereum mainnet. Okay, understood. So it's gonna save gas for most of the things. Okay, specification, it doesn't matter. It says something. I don't know what these two are, but maybe some academic writing, how we should interpret these words. So if you want to read these two, you can go ahead and do that. I'm not gonna. Aggregator, a new ERC4337 entity contract. User operation entity contract. Aggregator, a helper contract trusted by accounts to validate an aggregated signature. Bundler slash client whitelist the supported aggregators. Okay. Okay, let's see. Using signature aggregator, using signature aggregator. A signature aggregator exposes following interface. Validate user of signature. Okay, that works. Aggregate signatures. View function. Okay. This is also view function. This is also view function. Okay. An account signifies it uses signature aggregation by returning its address from validate user op. Okay, for this we'll go to VS Code. VS Code I account Yeah, you see this part. Validation data. Packed validation data uses underscore packed validation data and unpack to encode and decode. Signature authorizer. Return 0 or 1, otherwise return address of an authorizer contract. Tool. Then 32 bytes, right? So we have to use underscore pack validation data, this function. Roll that, copy. Well, let's remove this. No. Is it in helpers? Yes. Validation data. Now we can just go to type definition. We can use this struct, pass the aggregator address 00, and it will construct the validation data for us. In simple account, here we are returning this, right? Instead of this, we are going to return the other value. So the value will construct, which is validation data, then address of the aggregator 00 if logic is correct. Rest thing, all of the remaining things will stay same, just this part will be different, and this will also remain same. Let's remove this. We don't need console logs. Are there any more console logs? No. Okay, back to our specification. We understand this. During simulated validation, this aggregator is returned to bundler as part of aggregator info field in validation struct. Okay, we haven't seen this function. It's in the contract. The contract which is named EntryPoint simulations, and we haven't seen it. Okay, all aggregator must be staked. Is it similar to paymaster or account factory? At least one of those needs to be staked, but that is some off-chain thing. That's not related to on-chain. Okay, I'm not sure if it is, but let's see. These entities need to be staked. Okay, the bundler for the bundler should first verify the aggregator is not throttled or banned according to ERC 50 no 7562 rules. All those rules are for writing a bundler, not for smart contracts. To accept the user operation, bundler must call validate user op signature to validate user operation signature. This method must return an alternative signature that should be used during bundling. An alternative signature is normally an empty bytes array but can also contain some data for account. I didn't understand anything. So, to accept user operation, bundler must call That I understood. Then it's saying we're gonna return some alternative signature. But what this alternative signature will be? Because we don't have private key, so it can't be ECDSA. Like can you sign a message with smart contract? Probably not. Like most probably not. What this alternative signature will be? Okay, the bundler next point. This the bundler must call validate user op a second time on the account with user operation using the returned alternative signature and make sure it returns the same value. Okay, don't know. We have to see the example. Implementations of aggregate signatures function must aggregate all user op signatures into one value. So that's where maybe BLS signatures will come in to picture, where we have multiple signatures and that will be aggregated into one. Not Note that above methods are helper methods for bundler. The bundler may use native libraries to perform same validation and aggregation logic. Implementation a valid of a validate signatures function must verify the aggregated signatures validity for all user operations in the array and revert otherwise. This method is called on chain using. Okay, it just validates user operations, signatures of user operations using that function. Bundling changes in addition to steps described ERC4337 during bundling. Described in ERC4337 during bundling, the bundler should sort user ops by aggregator to create the list of user ops per aggregator. For each aggregator, call aggregate signature to create aggregated signature and update the user ops. New entry point function ERC437. We define the following. Yeah, we know this. Okay. An account that works with aggregated signature should return its signature aggregator address in the authorizer return value of validate function. It may ignore the signature field. Understood. We saw how validation data is packed. Okay, this function is not in a simple account. Oh, okay. So we need to add one more function here. Can do this. It may ignore signature field. Works. Handle aggregated ops. Can handle a batch that contains user operations of multiple aggregators and also requests without That's a request without any aggregator. Okay, that doesn't relate to us because we are not writing entry point. Handle aggregated op performs the same logic as handle ops, but it may transfer the correct aggregator to each user op and must call it must call validate signatures on each aggregator before doing all 4 account validations. Okay, validate signatures is function in the aggregator is a function in the aggregator, not on the contract. Transaction rejected because wallet specified unsupported signature aggregator. The data field should contain aggregator value as returned by accounts validate user op. Let's go to I'm in the VS Code. Okay, validate user op is function in our contract. Next, rational account returning the alternative signature. When using an aggregator contract, the account delegates its ability to authenticate user operations. The entire contents of what? The entire contents of okay here something messed up. Let's refresh. We don't know. This line is cut halfway. Uh, bro, this is only half sentence. I can't make sense of this. I know I'm dumb, but not that dumb. The entire contents of in order to allow no, that's a broken sentence. Ignore that. In order to allow the validation function of account to perform other checks, the validate user of signature function generates a byte array that will replace user operation signatures when executed on chain. Backwards compatibility. As ERC4337 was created with signature aggregation on the roadmap, no modifications are needed to deployed EntryPoint smart contracts. This proposal introduces new features without affecting the existing ones and does not break backwards compatibility. Understood? Security consideration, malicious aggregator. Aggregator contracts are among the most why there are spelling mistakes and broken sentences in the specification. Most of the trusted contracts in the entire ecosystem, they can authorize transactions on behalf of account and they can validate large number of transactions in simple storage change. Both account developers and block builders should be extremely careful with selection of aggregator contracts that they are willing to support. Understood? Then citations, we can ignore citations. Like there is nothing to read. That's what I wanted to say. Okay, we understood. I understood few things. where validate signature of should return a value for each user op, and then account will also have a function which returns same value. Then aggregate signatures, this is the thing that bundler will call, and validate will be called by entry point. Let's go back to VS Code. Entry point, and we are seeing handle aggregated ops. In that, it's calling validate signature. It's in the for loop, right? So what for each account, it will do the whole thing. Operations per aggregator. Total ops length, ops user ops info. Okay. Aggregator validate signatures. OPS signature. Try catch. If it reverts, we are giving this total ops. Act user operation aggregator. User operation per aggregator. OPA per aggregator 1. It's calling A. Oh, sorry. A is just I, basically. User ops, all data, aggregator. Well, it's doing the same thing again and again. Now we can check our ERC4337. No, ETH infinitism account abstraction. Okay, I want to see the example. Samples, and here is it utils? Or they haven't written that. Execute batch. Okay, I guess there isn't. Okay, let me zoom in. We have simple account. In utils, we have multiple things. But we don't have no, there should be something. Source. not source. I aggregator is there. 1, 2, 3, 4, 5, 6, 7, 8, 9. In the VS Code we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I aggregator is not used anywhere. That's not good. I thought I could take a help of that. Okay, ignore this. So tomorrow we have to, what we have to do is basically map out the flow, how this thing's supposed to work, and then start writing some code. Today we just read this part, what it needs, no, not needs to, what this is doing. So that's what we read, how the aggregation supposed to work. But in account abstraction repo, there is no example of aggregator that they have written, or at least yeah, that's, I'm not seeing it here, so there isn't one. Okay, cool. Let's go back to VS Code, commit our work, git add, git commit. What was this? Simple account test fix and simple account and user operation lib tests fixed dash m work done on 12th Jan 2025 stream link, and let me copy that. Copy, get push. Cool. Okay. Hopefully you like the stream. There wasn't any, there wasn't much to like. So anyway, if you like the stream, hopefully I'll see you tomorrow. And you know we what we have planned for tomorrow is basically map out the flow and then start writing the code, mm, and not wait for everything to be in place, or at least find an example. I mean, that's good too. Okay, cool. That's the stream. Have a nice day. Bye.